Vinita drives a car which has 4 gears. The speed of the car in the 4th gear is 5 times its speed in the 1st gear. So, gear 1, gear 2, gear 3, gear 4. Speed in the 5th gear is 5 times the speed in the 1st gear. This is x, this is 5x. Brilliant. The car takes twice the time to travel a certain distance in the 2nd gear as compared to the 3rd gear. In the 2nd gear, it takes twice the time. That means 3rd gear, it has twice the speed. Same distance. 2nd gear, it takes more time. It's slower. Twice the time as in 3rd gear. So, 3rd gear speed should be twice 2nd gear speed. In a 100-kilometer journey, if Vinita travels equal distances in each of the gears, she takes 585 minutes to complete the journey. 100-kilometer journey. So, distances, equal distances, 25, 25, 25, 25. In this scenario, time taken is 585 minutes. I don't like 585 minutes. Hours, 540 minutes is 9 hours. This is 9 hours and 45 minutes. Or 9 3 by 4 hours, 39 by 4 hours. This is in kilometers. I'll keep that in hours. I'm dealing with kilometers per hour. I like that unit. Or we could very well have kept it 585. There's no harm. Kept it 585 minutes. Then we are imagining speed in terms of kilometers per minute. That's all right. Absolutely nothing wrong there. Instead, if the distances covered in the 1st, 2nd, 3rd and 4th gears are 4 kilometers, 4, 32 and 60, adding up to 100, yes. Then the time taken in minutes, oh, I thought they'll give us this time also, and then we'll have to find x and y. Turns out he's saying, hey, what is the time taken in this scenario? It's a little weird, because I know that with this, we can frame a beautiful equation which says x by 25 by x, distance by speed, plus 25 by y, plus 25 by 2y, plus 25 by 5x is equal to either 39 by 4 or 585, whichever one works for us. And so I think if it is kilometers, I like kilometers per hour and hours. But you can keep it in minutes. Let's look at the question. The question says time in minutes for this one. So maybe we can keep it in minutes. Doesn't matter. And the units have to be consistent. They don't have to be one thing. Right? So I thought if we write this, we'll get x and we cannot get x and y. I thought maybe an equation in x and y will come from here. The equation in x and y will come from here, and we can solve for x and y. The question directly asks, what is the total time taken in minutes to complete the journey for this one? It's a little tricky, little weird. But let's power on. Let's keep doing this. For this equation, if we do 4 by x plus 4 by y plus 25 by 2y plus 25 by 5x, what is this equal to? Lovely. The question is asked for us in minutes. So I'm going to shift this to minutes and then do it like that. You could have done it in hours and then come back to minutes. It won't matter. Right? So now there is an equation in x and y. It's an equation in x and y. If you have two equations in x and y, we can solve and find x and y. But that's not the case here. So there should be something in the equation that gives it away. We have to back ourselves and say, hey, let me find this one. Lovely. So 25 by x plus 25 by 5x. 25 by 5x is 5 by x. So this is 30 by x. We'll reframe that equation. The last one. The first one, sorry. 25 by x plus 25 by y plus 25 by 2y plus 25 by 5x is 585. 25 by x plus 5 by x is 30 by x. Plus 50 by y plus 50 by 2y plus 25 by 2y is 75 by 2y. Here x LCM is x, there LCM is 2y. This is equal to 585. The other equation, 4 by x. I've written 25 and 25. I need to fix this. This is absolutely wrong. Let me fix that. This is 32 by 2y and 60 by 5x. I just copied this. I should have copied this. And so 4 by x plus 4 by y plus 32 by 2y plus 60 by 5x. 60 by 5x is 12 by x. 32 by 2y is 16 by y. I'm going to write this down there and then simplify that. 4 by x plus 4 by y plus 32 by 2y plus 60 by 5x. What is that equal to? This is 4 by x, that is 12 by x, 16 by x, 4 by y plus 16 by y plus 20 by y. We cannot solve and find x and y, that much I know. So what I'm thinking is every possibility that this part into something will be this part. It's a simple ratio. If I know x plus y, I can find 2x plus 2y. If I know x plus 3y, I can find 2x plus 6y. The ratio of the coefficients is the same, then I'm through. And so 16 by x plus 20 by y. We think 1 by x and 1 by y, 4:5 the ratio. We can imagine this as 60 by 2x plus 75 by 2y equal to 585. The coefficients of 1 by x and 1 by y, 16 and 20 here, 60 and 75 here. The ratio of the coefficients is 4:5. I'm through. I can find this. And exactly how we find it, how do we find that ratio, we'll come to that. But if I know 30 by x plus 75 by 2y, I can find 16 by x plus 20 by y because the ratio of the coefficients is the same. So to back ourselves and then decide to find the ratio. So 30 by x into what gives us 16 by x, 75 by 2y into what gives us 20 by y. And so 30 by x into 16 by 30. This number into 16 by 30. I'm just going to verify that. 30 by x into 16 by 30 will give us 16 by x. 75 by 2y into 16 by 30. This becomes 8. 75 by 30, I can cancel a 5. 15 by 6. 8 by 6 is 4 by 3. 15 by 3 is 5. This is 20. Brilliant. So this part into 16 by 30 gives me this part. Or my time taken will be 585 into 16 by 30. This question quite brilliantly has told us ax plus by equal to c, and then asked us to find kax plus kby. We cannot find x and y. There are not two equations, two variables, only one equation and two variables. But if this is the case, then I know this is kc. The multiplying factor in this case is 16 by 30, which is 8 by 15. 585 should be divisible by 15. Yes, it is. I'm going to directly divide by 15. 40 into 15 is 600. This is 39 into 15. 39 into 8. 8 9 so 72. 2 7. 24 plus 7. 302. 312 minutes. Absolutely brilliant question. When I first solved it, I thought, okay, x and y, I can't find x and y. That gave me, I was reading this question to expecting to find that in this combination, it will take 433 minutes. Find the speed in second year or something like that. That didn't happen. But I hang in there and then solve it. The total number of positive integer solutions of 21 less than or equal to a plus b plus c less than or equal to 25 is 21 less than or equal to a plus b plus c less than or equal to 25. A, b, c are positive integers. So we're thinking about 21, 22, 23, 24, 25. What I'm going to do, I'm going to say, hey, to simplify this, let me solve for a plus b plus c equal to 21, where a, b, c are natural numbers. There's a standard formula for this, n minus 1, c, r minus 1. I'm going to see if we can arrive at that formula. Imagine this is 21 ones. 21 ones placed on a board like this, or 21 pieces, sticks placed. And then you say, I'm going to take these sticks and put them into 3 baskets. I'll call this basket as A, this is B, this is C. So 1, 2, 3, the first 3 sticks go here, the last 4 sticks go there, the remaining sticks, which should be 14 sticks, go into B. The different ways I can gather these sticks, I get different combinations for A, B, C. All good. So another way of imagining this the same scenario. So instead of putting them in 3 baskets, I'm practically separating them into 3 piles. First few ones, middle few ones, last few ones. Either sticks or ones, doesn't matter. Or I'm saying effectively, instead of doing this whole stick thing, I can say I'm going to put some plus symbol in between. If I put a plus symbol here, the first number becomes 3. If I put a plus symbol here, the last number becomes 4, the middle number becomes 14. Or anyway, if you think about it, the number of ways of carving this 21 into 3 pots is nothing but the number of ways of planting plus symbols here. The plus symbols were put here and here. It is 2 plus 2 plus 17. They were put here and here. Probably 1 plus something else plus 3. So the number of ways of breaking it into 3 numbers, 3 natural numbers A, B, C that add up to 21 is nothing but the number of ways of putting those 2 plus symbols in between some 2 ones. How many such slots are there? Between any 2 consecutive ones, there is a slot. There are 21 ones here, so there are 20 such slots. Obviously, I can't put right at the beginning, I cannot put right at the end. Because if I do that, then one of the numbers becomes 0. I want all 3 to be positive. In how many ways can this be done? 20 slots, select 2 of them, 20 C2. So A plus B plus C equal to 21, positive integer solutions is 20 C2, n minus 1, C R minus 1. In our case, A plus B plus C could be 21, 22, 23, 24, 25. Or the total number of ways of this happening is 20 C2 plus 21 C2 plus 22 C2 plus 23 C2 plus 24 C2. 20 into 19 by 2, 21 into 20 by 2, 22 into 21 by 2, 23 into 22 by 2, 24 into 23 by 2. 19 into 10, 190, 21 into 10, 210, these two add up to 400, 21 into 11, 231, 23 into 11, 253, 23 into 12, 253 plus 23, 276. These two add up to 400, I can add just these 3, 9 plus 1, 10, 0, 1, 3, 5, 1, 8, 13, 16, 6, 1, 3, 5, 7, 760 plus 400, 1160. Very nice, very simple question. Once you know the framework n minus 1, C R minus 1, this becomes super cool, super straightforward. The product of the roots of the equation log to the base 2, 2 log x to the base 2 the whole square minus 5 log x to the base 2 plus 6 equal to 0 is. Simplify this, log to the base 2 of 2 power that, I can say it is log x to the base 2 whole square minus log 2 to the base 2 minus 5 log x to the base 2 plus 6 equal to 0. Log 2 to the base 2 is 1. So this is nothing but log x to the base 2 whole square minus 5 log x to the base 2 plus 6 equal to 0. Say log x to the base 2 is equal to y, y square minus 5y plus 6 equal to 0. So it's quite simply y minus 2 into y minus 3 is equal to 0. Y is 2 or 3. Y is log x to the base 2. So log x to the base 2 is 2 or 3. Or x is 2 power 2 or 2 cube. 2 square or 2 cube. 2 square is 4. 2 cube is 8, or x could be 4 or 8. 4 will work and 8 will work. The question is product of the roots of the equation. The two roots are 4 and 8. Product of the roots is 4 into 8, 12.